All right, welcome to Graphing Linear Inequalities in Two Variables, Part 1. Now, first of all, what are we kind of talking about with this word inequalities? Well, we're talking about things like this. Say we wanted to graph y is greater than or equal to 1/2 x minus 1. Okay, now this is very closely related to a line which would look like this. So there's a little bit of a difference here because the equal sign got swapped out with an inequality. But that being said, the graph really is based on this related linear function. So when we go to graph this thing, oh, by the way, when it says in two variables, that's because there's an x and a y. So we've got two variables going here. And typically when we graph with two variables, that means we're going to be graphing on the grid where you have an x-axis and a y-axis. So this is kind of a step-by-step approach. Step 1, we graph the related line. So we graph y equals 1/2 x minus 1. Now we know how to do that. We can either use the idea of the slope and the y-intercept, and that's a pretty good way to do most of these. If we had a different equation that wasn't presented in this form, we might just use the table of values. So, a couple of choices on that. Now, once we do the graphing, there's one thing that's different, so that's going to be step 2 here, between an inequality and the equation. With the line, you're done. You graph the line and you're done. Step 2 with inequalities is you have to shade. You have to shade either above the line or below the line. So you kind of set up zones. So above or below. And you have to determine which it is. Do you shade above the line or below the line? I'm going to show you how that works when we get there. And I think what we're going to do is just clear the screen and throw up the grid and show you what the end result looks like. So we're going to clear this out and we're going to paste in the grid. Okay, so we're ready to go. So in case you forgot what it looked like, we're trying to graph this guy. Y is greater than or equal to 1/2 x minus 1. So I'm going to use the y-intercept is -1. So right there. And then I want to build a slope of 1/2. So I want to have a rise of 1 with a run of 2. So basically like this. Okay. So I want to build this line here. So I'm going to just get the line drawing thingamabobber here and then try and do a decent job of it. Let's see here. Okay, that looks pretty good. I'm going to plot that in there. Okay, so there's my line. Okay, and obviously this goes off forever in both directions. So that's step 1 all done. Now step number 2 is I got to shade either above or below. And the reason is the points that make this inequality true are more than just the points that are on the line. There are all these other points that are maybe the points that are above or maybe the points that are below. Now there's 2 methods here for figuring out which way to shade. I'm going to show you both methods. The one method is to get a test point. Okay, and that's pretty easy to do. What you want to do is just pick some really nice, easy point that's either above or below and see if it gives you a true statement with your inequality, in which case you would shade where that point came from. Or if it gives you a false statement, then you know, oh, I got to shade the other side. Because remember, you always shade the true zone. And that would be all the points that would make the inequality true. So I'm going to pick a pretty easy test point here. I'm going to use 0, 0. So I'm picking this guy here that's just above. Okay? If I put 0 in for y and 0 in for x, this is what I get. I get 0 greater than or equal to 1/2 times 0 minus 1. So let's look at what we have and determine if this is true or false. Is 0 greater than or equal to -1? Well, Yes, it is. So this is true. Now that means that if this point is true, it means this point is true, and this point is true, and this point is true. In fact, all the points that are on this side of the line are true. So what we do to indicate that is we shade it in. So I'm just going to do a kind of a cheap little shading job here. That's good enough. You know, it basically shows, yes, this is the true zone. True zone. Okay, any of these points in this zone will make the inequality true. All right, so that is the one method that I like to use, the test point. The other method, I left a little bit of room here, requires a certain amount of interpretation, but it's very speedy. If you have y and then all the rest of the stuff on the right, you can kind of read it like this. The y represents the part that you want to shade. So this is the shade part represented by y. And then this stuff over here, the 1/2 x minus 1, well, that tells us where our line is. So this is the line. Okay. And so what this says, if you just read this as a sentence, it says, well, we want the shade part, or the shaded part, to be greater than or equal to the line. So shade part greater than the line. Now, when we're talking vertical stuff, okay, when we're talking up and down on a grid, where is the greater than stuff? Well, greater than stuff, or the bigger stuff, is the higher you go. And then you get the small stuff, smaller numbers, the lower you go. So if we want the shaded part to be greater than the line, and we got a line going like this, well, to be greater than the line means we want to be above the line. Okay, so you can read this as a kind of sentence. It just tells you, oh yeah, shaded part above the line, greater than the line. And you can see it matches what we got when we used the test point method. All right, so that's how you graph these linear inequalities. Now there's one more thing I got to tell you here, and that is there is a difference between this graph, the one we just did, and what if we just had this? Okay, what if there was no equal thing written underneath? So it's just greater than. The difference is, I'm just going to do a cheap little graph here. This one, the line that you draw is a solid line. And it's solid because you're including all the points that are on the line. And then, as we saw, you shade above. So it's a solid line and you shade above. This one here, it's a dotted line. Okay? And the reason it's dotted is that that shows the points that are on the line do not make the inequality true. So you're kind of, by showing it with a dotted line, you're rejecting the points that are on the line. The only points that actually make the inequality true are the points that are above the line, the shaded part. Okay? So if you ever get this symbol here or this one here, where there's no little equals line, you have to make sure you draw the line dotted. Okay? And otherwise, if you've got these guys here with the little equals, then you make sure your line is solid. All the rest of it is exactly the same. You still shade the true zone and all the rest of it. All right, well, that's where I'm going to stop with this first introduction to graphing linear inequalities.